Good day, I am Riza Mayhaos, a Bed 2 student, Section A. For today's video, I am going to discuss about the understanding of an earthquake, weathering, erosion, and soil. So we will go first of an earthquake. So what is an earthquake? Earthquake is an intense shaking of Earth's surface. So the shaking is caused by the movement in Earth's outmost layer. So why do earthquake happen? Although the Earth looks like a pretty solid place from the surface, it is actually extremely active just below the surface. The Earth is made of four basic layers, so a solid crust, a hot nearly solid mantle, a liquid outer core, and a solid inner core. So the solid crust on the top stiff layer of the mantle make up a region, which is called lithosphere. The lithosphere is a continuous piece that wraps around the whole eggshell. It is actually made up of giant puzzle pieces called tectonic plates. Tectonic plates are constantly shifting as they drift around the viscous or slowly flowing mantle layer below. So this non-stop movement causes stress on Earth's crust. When the stresses get too large, it leads the cracks called fault. So when tectonic plates move, it also causes movement at the faults. An earth is the sudden movement of earth crust at a fault line. So the location where an earthquake begins is called the epicenter. An earthquake's most intense shaking is often felt near the epicenter. However, the vibration of earthquake can still be felt and detected hundreds or even thousands of miles away from the epicenter. So, how do we measure earthquake? The energy of an earthquake travels through Earth in vibration called seismic waves. Scientists can measure the seismic waves on instruments called seismometer. A seismometer detects a seismic waves below the instrument and record them as a series of zigzags. Scientists can determine the time, the location, and intensity of an earth from the information recorded by the seismometer. This record also provides information about the rocks of the seismic waves travel through. There are building and properties in devastating effect of an earthquake. First, a damage to building. A high magnitude earthquake can lead to a complete collapse of building. Debris from collapsing building is the main danger in the course of an earthquake because the falling effects of a huge heavy object can be deadly to humans. Next, we have damage to infrastructure. Earthquake can cause electricity line to fall. This is dangerous because the exposed live wires can electrocute humans or start fires. Major earthquake can cause rupturing of roads, gas lines, and water pipelines. Broken gas lines can cause gas to escape. So next we have landslides and rock slides. When an earthquake occurs, large rocks and sections of earth located uphill can be dislodged, consequently rolling rapidly down into valleys. Landslide and rock slides can cause destruction and death to the people living downstream. So next we have earthquake can result in floods. High magnitude earthquake cause instigate cracking of down walls, collapsing in the long run. This would send raging waters into nearby areas leading to massive flooding. So next we have earthquake can trigger tsunamis. A tsunami is a series of long high sea tremors sparked by an earthquake or volcano eruptions under the sea. A tsunami can wipe out an entire surrounding coastal or in population. And lastly, earthquake leads to liquefaction. Liquefaction is a phenomenon where the soil becomes shattered and loses its strength. When sediment consisting of a high water content are subjected constantly trembling, water pressure held in the sediment pores slowly increases. So can earthquake be predicted? To date, scientists have not been able to predict earthquake. Many modern techniques have been used. Unfortunately, none of them has worked. If any such a tools built to predict earthquake, many lives could be saved in the future. The only thing that you can do is to educate yourself about the earthquake management and be vigilant in times of the disasters. So next topic that we are going to discuss about is weathering and erosion. Natural forces have been power to change our landscape by weathering, erosion, and deposition. So what is weathering? Weathering is a process where rock is dissolved, worn away, and broken down into smaller and smaller pieces. So these are mechanical, chemical, and organic weathering process. So first, let's go the organic weathering. So organic weathering happens when plants break up rocks with their growing roots or plant acids help dissolve rock. Once the rock has been weakened and broken up by weathering, it is ready for erosion. So erosion happens when rock and sediments are picked up and moved to another place by ice, water, wind, or gravity. So next we have chemical weathering. Chemical weathering physically break up rock. One example called frost action or frost shattering. Water gets into cracks and joints in bedrock. When the water freezes, it expands and the cracks are opened a little wider. Over time, pieces of rock split off of rock face and big boulders are broken into smaller rocks and gravels. This process can break up the bricks on the buildings. So next we have chemical weathering. Chemical weathering decomposes or decays rock and minerals. An example of chemical weathering is water dissolving limestone. When ice melts or wind and water slow down, they can carry as much as sediment. The sediment is dropped and deposited in the landforms. So next topic we are going to discuss is all about soil. So what is soil? Soil is a loose rock fragment and decay from weathered rock mix up organic materials. So as you can see in the picture, air represents as humus, where it is a dark organic material, while B and C represents as soil, where it is a mixture of minerals, gases, and dead organisms. So D represents as regolith, which is the layer of the weathered rock fragments. And E represents as bedrock, where it is a solid unweathered rock. So there are two types of soil. We have first residual and transported. So residual is the parent material is the local bedrock, while the second one is transported. Transported developed from parent material that has been moved far from original location. So that's the end of my report. I hope you've learned something.